So in this video, we will work on how can we do the question number D, test the Q statistic and test the Q statistics and report the finding. Okay, remember for the Ljung-Box statistic, we use this test to test out if our result is follow the white noise. So basically, there is no more autocorrelation exists after we send in our series data to the black box we identified. So if we cannot reject a hypothesis, and we will know the model works well. If we actually end up reject the hypothesis, then we know the model we find is not the best to capturing the pattern of the time series data we are trying to forecast. So in order to do that, we need to have that Ljung-Box statistics. So given we already have this result, Ljung-Box. So the big question here for many students is that if you don't know how to get this result, you need to watch the previous video. So in this video, we will focusing on how can we do this hypothesis testing to see if our, in this case, is ARIMA 202 model are able to capturing the pattern in our time series data so that we only have the white noise left. Okay, so first of all, set out the 3 steps. So for the HO in this hypothesis is there is no autocorrelation in the data after the ARIMA model. Okay, and then the H alternative will be opposite, right? There is autocorrelation in the data after the ARIMA model. Okay, so this is my hypothesis. So in order to do that, the statistic we already have. So our Q statistic is equal to the 8.2. Okay. So based on the text, so the next is we need to know the critical values. So in order to calculate the critical value, basically if the Q statistic calculated by the ForecastX is smaller than this critical value, and we know that the HO cannot be rejected, so our forecasted model we identify here is working well to predicting our time series data. So in order to calculating this critical value, we will use the formula called chi-square, CHISQ dot INV dot RT. Okay. So let's see our statistic test. We are using the significant level at 0.10. So that's what we use in the textbook. But if you want to make it in the test is stronger, and we should use 0.05 or 0.01. Okay. So I just used whatever the textbook we used. So far we can use a 0.10. And then the difficult part is the degree of freedom. Okay. So remember in the lecture, we mentioned that by default, the ForecastX will choose the degree freedom M. When we calculate in the degree freedom, it is equal to M minus P minus Q. Okay, so M minus P minus Q. So the M, it is the lag we use to calculating the Ljung-Box statistics. So if the data has no seasonalities, as we can see in this case, we don't have seasonality because the second part of this box here, as you can see, are all zeros. All the value here is 0 means we don't have any seasonality. So without seasonality, our Ljung-Box, it will choose 12 as the lag. Okay, so we actually can adjusting that lag, and I will demonstrate that in the next questions. How can we adjust in the lags? So by default, we're going to use 12. Okay, so M equal to 12, and the P equal to 2, Q equal to 2. So here it will be equal to 12 minus 2 minus 2, right? So that will become my degree of freedom. And then I will close the parentheses. And then we are receiving the value 13.36. So this is exciting critical value because our Q statistic is smaller than critical value. Therefore, since Q statistics is smaller than the critical value, we will conclude that there is no autocorrelation in the data after we applied ARIMA 202 model. Therefore, the model fit the data well. Okay, great. We actually find the model we are looking for. So ARIMA 202 is the model we're going to use to estimating our this time series.